And welcome back to question 4 of 5 of the second set of difficult GCSE problems. This one, as you can see, is an index question. I'm pretty sure it comes from a non-calculator paper, but either way, you shouldn't need a calculator to do this question. Have a go, pause the video, you know how this works, come back, check you've got the right answer. All right, so let's see how you've done. Now, these sorts of questions, this isn't a show all steps, this is just a work out the value question. So it kind of doesn't matter how you've got there, but it's still good practice to lay your working out clearly. So what I would do is I would label the 3 equations that I'm given. It just allows me to refer to them then in the question when I'm doing some working, rather than just doing a bit of working everywhere that you can't read properly. Then equation 1, I can rewrite as 2x equals 2 to the power of n. So far so good. And then let's remember that 2 to the cube root is the same as 2 to the third, and because it's 1 over 2 to the third, that's minus a third, so it's 2 to the n times 2 to the minus a third. And using my index rules, if I multiply powers, I add them together, so that must be the same as 2 to the power of n minus a third. Now, the key to these questions, if you haven't seen these sort of questions before, because that's 2 to the power of something, and that's 2 to the power of something, and these things are equal, it must be the case that x is equal to n minus a third. So I've got my first equation, which I'm going to call a over here. Then equation 2. Now, this one's arguably a bit easier, but let's give it a go. So I can see 2 to the power of y equals, and if I just write it down this way, it's slightly easier to understand. So the square root of 2 is the same as 2 to the power of a half, and I'm still doing that to the power of 5. Then the brackets rule tells me that I multiply 5 by a half, which gives me 2 to the power of 5 over 2. Now again, because my base values are the same of 2, my indices must be equal, which means that y is equal to 5 over 2. So I've got an expression for x, and I've got an expression for y, and what I also have is equation 3, is I have an equation that tells me that x plus y is equal to 8. So let's just substitute that in, because remember what I'm trying to do. I'm trying to find out the value of n, which means I want to eliminate all my x's and all my y's. So I can say that n is equal to the a equation plus the b equation, which is 8. Do some fractions, so make the denominators the same. So I've made every denominator 6. So n minus 2 over 6 plus 15 over 6 is 48 over 6. Put everything else on the other side that isn't an n, and that's going to tell me that n is this equation here, which gives a final value of 35 over 6. Again, if you got this far, well done. Nice question. If you know your index laws, it's pretty straightforward. If you don't, good sign you just need to do a bit of practice, because these questions are now a lot more common. As ever, thanks for watching the video. Please do leave a like, please do subscribe, and please do leave a comment if there's anything you'd like me to follow up on. Thanks all. Bye.